Welcome to IoT Leaders with me, your host, Nicole, CEO of Eseye. And today we have a two for one. Steffen Sorrell, who runs research at Kaleido Intelligence, been on the pod before, and Larry Socher, also been on the pod before, who works for Eseye and is sort of our futurist and technologist all rolled into one. We're talking about two main subjects here. One is the fascinating news around Porsche Europe obsoleting the Macan because of a regulatory compliance change by the United Nations. And if you don't know what that's all about, you're about to hear about it. But essentially, Stefan believes that cost them between $1 and $2 billion of revenue as a result of what they had to do. And it's all to do with IoT and traceability and supply chain visibility, etc. And then secondly, we get onto the really meaty subject of 5G and how on earth can you implement 5G across a federation of multi-operators, multiple operators acting together, and what does the industry need to do, and what role does trust and auditability and security play in the delivery of 5G to the endpoint, and as a result of that, how does the device play a role in requesting or triggering what 5G services need to be delivered. So it's one for the people who are looking at the technical aspects of the of IoT, and particularly at the operators end. And we get into quite a bit of interesting detail and speculation, and even finishing with a prediction of what is going to happen next. So we bundled it all up into this podcast. And so without further ado, we'll get going with my IoT Leaders podcast with Steffen Sorrell and Larry Socher. Here we go. And today I've got two guests on the podcast. First of all, I've got Larry Socher, who is our SVP of Products and Strategy here at Eseye. Hello, Larry.
Hi, Nick. Great to be back.
And secondly, I have Steffen Sorrell. Now, Steffen is the Chief of Research at Kaleido Intelligence. And for those of you who are regular listeners to the IoT podcast, you'll think, I've seen this guy before. I've heard his voice before. And actually, this is Steffen's third appearance on the podcast. So, Steffen, thank you for being our first guest to actually make three appearances on the podcast. Welcome.
Yeah, thanks. Thanks for having me again. Thank you.
Again, okay. And we've got just as a sort of heads up to everyone, this is a very technical podcast compared to some of the others. Often we look at business use cases, and we will indeed look at those. But here we're going to go fairly deep into telecom speak and look at a lot of the issues to do with security, compliance, auditability, implementation of 5G, and the how that will all come together in front of the user in a model where roaming itself is not the most reliable way of actually creating global connectivity. So all of that will get bundled together and into the topics that we're about to talk about on this podcast. So I'm going to start off with you, Steffen. Now, I was in December driving my car, and it's a Porsche Macan. And I read either late December or early January, I can't remember what I read, but it was in Autocar, a motoring magazine here in the UK. And it said Porsche are end-of-lifing the Porsche Macan, which took me a bit by surprise because I hadn't heard any announcements of that. And when I started digging, I actually then found out that it wasn't so much to do with the device, the car, as to do with an IoT issue around security and compliance, and a new regulation that had been introduced for automotive providers in certain parts of the world. It's all got a bit mysterious, but I believe you're the man who can shed some light on what happened. So what's your take on what happened?
Yeah, it's a very interesting situation. So it's the ICE, so the internal combustion engine variant of the Macan. They've had to stop selling it within the EU. And the reason is because of this regulation, the so-called WP29 regulation from the UN, really mandates that OEMs within automotive are going forward fully responsible for the cybersecurity and updatability of their vehicles. Now, if you imagine how vehicles are produced, it's from hundreds of different suppliers, loads and loads of different pieces of software. The OEM is responsible for ensuring that all of their suppliers are compliant with the regulation. It's responsible for ensuring that all of the software in the car can be upgraded throughout its life cycle. And as part of that regulation, they're subject to having to provide proofs, undergoing audits, and so on. And yeah, clearly, the Macan, at least the combustion engine version, the older variant, let's say, doesn't meet that regulation. So they thought it's probably cheaper to stop selling it in Europe rather than redesigning the whole vehicle itself. Now, I did some, let's say, some napkin maths on this, and I reckon that they're losing between $1 and $2 billion of revenue just for withdrawing this vehicle from the market before they wanted to.
And they've only just, as you say, I drive one, now rapidly becoming a collector's item, clearly. But I've been thinking about going to the EV or the hybrid, but that's only just been announced. Yeah. And so, yeah, as you say, they had to take action pretty quickly. So they'll have wanted potentially, we don't know, but potentially $1 to $2 billion drop as a result of a regulatory change. And what was interesting is you don't often, the first time I've ever heard it, you don't often hear about a telecom industry regulation change from the United Nations. I don't normally think about the United Nations issuing regulations that affect sort of the IoT, the component, the data, the compliance, the security. So why was it the United Nations and not, for instance, the EU?
I think it's because, as a whole, the automotive industry is at least trying to move towards the fabled autonomous vehicle. Personally, I believe that's many, many years away, but there are, things like advanced driver assistance systems, CV2X, so cellular vehicle to everything communications, are talking to other vehicles, people, infrastructure and stuff. And vehicles as a whole are becoming, it's a nasty word, but softwareized
It's awful.
in their architectures. So, this is about addressing cybersecurity and what is basically a critical piece of infrastructure that's several tons in weight, driving across everyone's road. You need to make sure that the cybersecurity in what is essentially now a very powerful moving smartphone is really up to scratch. And I think this is why someone like the UN's involved, tried to get as many members as possible signed up to this type of regulation.
And I believe currently it's EU and Japan. Have I got that right?
It's EU, Japan, and a smattering of other countries whose names escape me right now.
But not China, interestingly, because I guess their cars are typically, they made a huge push behind EV.
Yeah.
So they'll have much more modern technology. I guess they've got an advantage, is what I'm trying to say, when it comes to this, because they are already large. What do you call them? Large, heavy smartphones on the move.
Exactly. Yeah. Yeah. I mean, the Chinese OEMs have really, in terms of how they're architecting their vehicles, stolen a march on what the European and perhaps the North American OEMs are doing in terms of getting that architecture streamlined, at least so they can ensure that the vehicles are updatable throughout the life cycle. It's not to say other OEMs are not doing it right. Look at Tesla, did a large-scale software update, over 2 million vehicles quite recently. But let's see some other OEMs, some big-name OEMs in European markets do that. I would be surprised.
I was thinking as you were saying that story, Stefan, Larry, I'm going to ask you your take on this in a minute. One of the books that I read early in my career and occasionally reread is Sun Tzu, The Art of War. And the perfect strategy, the perfect war is when your opponent gives up before you even fire the first shot or attack or whatever. And in this case, you've got Porsche, huge European company with all these EV vehicles are about to flood the UK from China at half the price of current models, and you've got Porsche end of lifing a major product even before they arrive, which is kind of interesting, the effect that technology and standards can have. Larry, what's your take on all of this?
Well, first of all, let me talk about the automotive one. I mean, if anyone wants to know the importance of why you really have to get security right on it, you just need to go to YouTube or Google and just look at hacks of vehicles and what people can do remotely and shutting them down. So there's quite a few videos out there. People are remotely hacking in, shutting down a vehicle on the side of a road and stuff like that. And that's probably gotten 100 times worse. So it's critical that you do this. But similar industry. I mean, we've got I've been looking at carbon trading recently. We have a customer in that space, and I started to do a lot of research around it, about the importance of end-to-end trust and stuff. And one of the problems if you're familiar with the carbon trading market is, there's a lot of fraud that goes on. So this notion of end-to-end trust of these devices. So if I've got device out there that's like an EV charger and I get carbon credits for that and I need to get that to a carbon exchange, I really need to not only make sure that the device, is authenticated, it's the right device, it's doing things, but I need to guarantee that data from end to end. So not just, making sure the device is protected, but everything through the network up into the cloud and into that carbon exchange is validated. So we're starting to see some very interesting use cases of not just authentication, authorization, but also auditability. What happened? Did it actually do this? Has anything been tampered with? And one of the things that it's completely changed my perspective on is I never used to be a big fan of blockchain technologies. I thought it was, going way over engineered for protecting stuff. But all of a sudden, I'm starting to see some emerging use cases that have this end-to-end trust and protect, everything from authentication all the way from trust of the data and being able to secure and protect that end to end. And I've all of a sudden realized, hey, here's a very good blockchain application. So I think not only do we have the standards emerging, but also the technologies, start to use some of the technology we have out there, like blockchain, to solve some of these problems.
So in a way, it's sort of the next evolution of IoT. I mean, I know we have mentioned this before on this podcast in terms of our annual predictions report. We talked about trust being the next big issue. And when we did that, we wrote that in December, and little did we know, Larry, when you and I wrote the predictions report, but I think it was 2 weeks later, the Porsche decision would get made. Clearly nothing to do with us, but I mean, it's a pretty big deal. Somebody obsoletes a product. Their top seller, actually their top selling model of car in Europe, ahead of its time because of a United Nations regulation, this snappily named WP29, which I've got to believe probably stands for Working Party 29. It's not the most creative name for a regulation, but pretty effective. And I was going to use that as a springboard to go into the second subject for today's podcast, which is the telecom industry and the idea of this is one example that this happened to one company in one vertical. It may well happen to other companies. I guess we'll see what happens. But it's in automotive with the car and being responsible for the whole supply chain. Very hard for the car company to be responsible for hundreds of suppliers, as Stefan pointed out. But in a way, that's kind of easy pickings when you actually look at the problems of implementing 5G. And 5G, not just from one company's perspective, and we've been talking about this, and every conference is all about 5G, and most of the operators are putting, frankly, billions of dollars into 5G because of its potential. But then thinking about how do you do that? How do you deliver a service across roaming on 5G? And we'll probably get into eSIM, EUICC complications. But just for the moment, roaming. Now, Stefan, Kaleido Intelligence are famous. You know, your whole thing is you're the guys who get consulted a lot on roaming. So this must be a hot topic for your clients. So what's your take on how the implementation of 5G, particularly with regard to 5G with roaming and the fact that roaming agreements, frankly, aren't as stable as they look at all because they break all the time?
Yeah, I mean, we're in 2024 now. I mean, 5 years since the first 5G networks launched. And if we look at the market today, I mean, how many commercial services are there today for 5G roaming where you've got both the radio and the core network operating in 5G mode? So fully fleshed out, full-flavored 5G standalone, we call it. Today, there are zero. And I think people underestimate actually the complexity of what's been happening under the hood. So, you know, the 5G standard was developed. Unfortunately, not enough thought was put into the commercial model. And they just went, let's focus on 5G, secure by design, end-to-end security. Let's make it happen, assuming that every operator is going to say to every other operator around the world, I want to make an agreement with you. Let's sign a one-to-one agreement. And by that architecture, that makes it end-to-end secure. That's not how roaming works. Very often, there are other providers in the chain, so roaming hubs, service hubs, IPXs that transit the data across the world. And these are entities that can potentially open up a security hole because things like metadata, message headers, and so on, perhaps even the content of the message itself, can be read by those intermediaries before they pass it in. So it kind of breaks the end-to-end security model of 5G. So they've set up a group called the 5G Mobile Roaming Revisited, 5G MRR. And they've been talking on ways to, you know, solve this challenge to ensure that both the commercial needs are met for 5G roaming, as well as, you know, trying to stay as closely as possible to, you know, keeping with that with that secure by design principle. And this is one of the reasons why we haven't actually seen any true 5G roaming agreements today. And, you know, it really underlines that, you know, it's a very complex environment. Yeah, we need to look at things a little differently, perhaps, in future.
And for those people who perhaps didn't listen to your previous podcasts, episodes of this podcast with me, I know one of them in particular went deep on roaming agreements. And so just maybe as a little 30-second refresher, as I mentioned, you guys at Kaleido study roaming agreements, write a lot of reports around roaming and where it is. You go to a lot of conferences. Roaming, just a little education for people. Roaming agreements, they get cancelled a lot, don't they? I mean, they are pretty fragile. I think a lot more fragile than people think. Anything that's built on the assumption of everyone has a roaming agreement with everybody else is probably a flawed assumption, isn't it?
Yeah, I mean, that's right. As you say, agreements are broken quite often. There's a good example that's happened quite recently for Telefonica, for example, in the UK, has decided that some roaming partners will no longer be able to access its LTE-M network for inbound roaming. Now that's impacted certain service providers. It's happened with, you know, very short notice. As far as I can remember, it was like 2 weeks notice. And then, of course, you have that. You have also the fact that typically roaming agreements are much shorter than the life cycle of an IoT device, which can be often well over 10 years.
Yeah.
So as you mentioned, roaming, I mean, it's great, really quite a marvel. But on the other hand, the commercials behind it can often mean that it breaks.
It's temporary. One of the things that we always smile when customers say to us, "Oh, well, I'm talking to somebody else. We won't mention any names, but they've got a permanent roaming agreement with operator X." And to your point, there is no such thing as a permanent roaming agreement. There's a roaming agreement which is currently in place, but there is no contract in the world for a permanent roaming agreement. When you take the definition of permanent is, if you've got a smart meter, it's going to be in the ground, as they say, for 15 years. Do you have a contract guaranteeing that? Of course you don't. And so they break, and they not only break, but of course, often they want to just discourage roaming. So they don't contractually break, they just put what's called an access fee on it. And certainly we've seen access fees, which is essentially a price rise. But certainly we've seen access fees saying, well, we won't, operator A won't accept inbound roaming traffic from operator B anymore, unless, of course, you pay, it was about 6 or 7 pence, British pence per device, but we've seen some recently which are 30 pence per device. Well, 30 pence access fee could be 4 times the amount you're paying for your data.
Yeah, exactly.
It's basically breaking the roaming agreement without breaking the roaming agreement. So it's not something that can be relied on for IoT. And Larry, I want to look at it from a technical perspective, because I know you spent a lot of time looking at 5G and thinking about if ultimately the promise is, it's a lot of new use cases for 5G, which we've been talking about for this 5 years. I didn't realize it was 5 years, Steffen, that we've been talking about it, promising it. But also, technically the QoS, the web slicing, the URLCC, all of this is still not implemented, as Steffen pointed out, but it's even more difficult, isn't it, Larry, when you're trying to deliver it, not just across roaming arrangements, because you're not in control of the destination architecture, but in a world of federation. So in a world where the technologies such as SGP32 enable the IMSI to be swapped very easily, then actually you're hopping between networks. Therefore, you're hopping between different 5G implementation stacks. So how is that all going to work?
Yeah, and this is an incredibly difficult problem. So where Steffen just pointed out, end-to-end security and the roaming needs to be figured out. I'd argue that the quality of service is equally hard, probably even more difficult. And this is an area that I've looked at my entire career of just end-to-end QoS. So as soon as first of all, if you actually think about 5G, I'm a big believer that the real promise of 5G is URLCC, ultra reliable, low latency communication. So if you look at use cases like augmented reality, you look at autonomous fleets where you need a lot of low latency, real-time communications. Now, it's hard enough to deliver on one carrier's network, but when you're traversing carriers, you really need to make sure that you have end-to-end QoS between those two things that need to have that low latency, whether it's a device into the cloud or two devices talking to each other through those networks. And in order to do that, you've got to then orchestrate that QoS end-to-end. Now, go back to the world of IP and the internet. While it's incredibly powerful and flexible, getting end-to-end QoS is not easy. It's got to be all the way from device to cloud or device to device. So you really need a mechanism for being able to orchestrate that, starting in the radio access network. And we've heard the term network slicing, which is really making sure the right low latency communications is going through the radio access network, through the distribution network. But that then needs to be extended all the way through your software-defined network up into the cloud or to another device. And that needs to be orchestrated and stitched together end to end. And we've got a number of different technical and commercial barriers that are preventing that. starting on the technical side, it's taken a long time for the network providers, so the Ericssons and Nokias, to deliver the APIs, the network APIs, sometimes referred to as the network exposure function, to the applications to actually request that quality of service. So that needs to start. But then now that needs to be mapped into the distribution networks all the way back through the wide area network, and then either into the cloud or to the remote devices. Something needs to orchestrate that all together, and then that requires both commercial agreements that allow the interaction between these two capabilities, but then orchestrating end to end, interacting with the radio network, interacting with the software-defined network, even potentially interacting with the cloud providers to stitch up that end-to-end session. And then finally, you need something to trigger that. You don't want to have to be able to schedule, hey, I'm going to do an augmented reality session, or I'm going to do my fleets, so I'm going to have it done in advance. You need the device itself to actually request those resources. And there's been a big gap in capabilities, first on the orchestration side, but then even the devices to signal that.
Yeah, I'm going to come back to the device, but Stefan, maybe I can ask you first. You get involved, Kaleido, looking at a lot of the standards. You have to study them, you have to report on them, the initiatives in the industry. It seems like we're really lagging here. I'm still thinking about it was 5 years ago. It wasn't 5 years ago that we thought 5G was a good idea. That was a lot further back than that. But people were announcing 5G, we're going to get going. And even now, all these conferences, come to the 6G. I think I even saw an email the other day, someone inviting me to a 7G 7G conference, which I kind of assume was some sort of hallucinogenic drug, because we haven't even got 5G sorted out. But the standards bodies don't seem to have solved a lot of issues. Are there any other initiatives going on in this area that hold out promise for this coordination across operators that you're aware of?
Yeah, I mean, a very interesting work that's going on right now within the GSMA is the Open Gateway Initiative, and this touches on a little bit about what Larry was just talking about. So essentially, the idea is that there will be consumable APIs developed for various use cases, and one of the more interesting ones is the quality on demand API. So an IoT application can then request, I want to have this kind of latency or this kind of bandwidth, something like that, for example. That's a fantastic idea. But of course, when we talk about IoT and an ideal world of IoT, we want everything to be as consistent as possible, because if you start to run into troubles in various places, then you stand to potentially disrupt the project itself. So really what needs to happen is that all operators globally need to start collaborating on this initiative. So essentially you then form a level playing field for developers to access and make use of these APIs. So while it's a great idea in principle, I'm a little less optimistic about whether this gets rolled out globally and whether we can actually say, okay, it doesn't matter where I am for my IoT device, I can leverage this type of solution. I think that's a much more challenging issue.
It's always interesting when the answer is, and I think it's the correct answer, is ultimately it's great if everybody collaborates. But going back to, you mentioned at the beginning of the podcast, the UN. The UN was set up because everybody doesn't voluntarily collaborate. You need a governing body. You need a central institution that encourages collaboration. And we looked a lot at the industry issues here a lot, and during each podcast we just mentioned Eseye a short amount of time. But in this particular case, that's one of the reasons why we did our AnyNet Federation, which has currently got 16 operators in it, because we can collaborate. We can have a collaborative model. We've got a collaborative model across 16 operators where we can orchestrate the connectivity by federating it, distributing it with a choice of either roaming or localization in a common model, but each member of the federation operates independently, and each one could, if they wanted to, sell a global solution. So I think it raises the issue of whether or not the industry will all collaborate individually and collectively, and or there will be groups of operators who will collaborate in order to deliver the service and therefore have commercial advantage by being people who collaborate together, agree a set of rules which are implemented for them by an independent third party like ourselves or other people. Because without this collaboration, you really can't see how you can deliver an end-to-end service when somebody is not in charge of 70-80% of the architecture because they're distributing it. And as I say, SGP32 and eSIMs and the UICC seems to accelerate that and turbocharge it. And hopefully in 5 more years' time, we're not looking at the fact that there still isn't a use case out there. Larry, to finish, I wanted to just come back to a couple of points you've raised. One of the things, it seems to me, you said it's all about the device to do the trigger. And you also talked about the trust model and the blockchain in the context of automotive. Is it your view that this problem of doing it for 5G that we've talked about makes that even more important, that you have device resident intelligence that signals what it needs and the ability to have auditability and trust end to end to implement 5G?
Yeah, I mean, the device has to play an active role in this. You know, you can't just start at the APN or the packet gateway in the network. It really, and you can't even pre-configure these things. Sometimes they can be much more dynamic. Take an augmented reality session. I don't know, I may not know when it's going to happen, or even if I've got a fleet that's out there. So you really, you know, let's take the signaling first. You really want the device to actually request the resources, saying, hey, I need this end-to-end session, request the network to do it, and then have the orchestration end-to-end, you know, going in, doing the network slicing through the network exposure function, configuring the SDN all the way up into the cloud or to the end device. So it needs to be triggered from the device. We actually just published a patent on the network aware API. We're starting to implement those type of capabilities in Smart Connect to actually do that request. And then take the security side of it. There is no option. It has to start on the device. You have to protect everything on the device. It's the thing that, like in the case of carbon trading, needs to validate that this is the actual device. It's measured this. It's securing it. There's no, you know, it's then doing audit and auditability end to end. So you really have to have the device participate in that. You may be able to manually stretch and configure the QoS, but even it's really, you're better off signaling from that. So in both instances, the device should really initiate this and participate and drive it with the network then orchestrating it on its behalf.
All right. Okay. I'm going to bring this to a close. And Steffen, I'm going to put you on the spot. I mean, anyone who's been on this podcast for 3 times as a guest should be able to answer a couple of rapid fire questions that we didn't talk about in the rehearsal.
Okay.
So here we go.
This should be interesting.
Should be interesting. All right. Question number 1. I'm going back to the Porsche story. I think it's absolutely fascinating to obsolete your number 1 selling car ahead of time. They were going to anyway because the EV thing was there, but they've created a gap because they weren't ready to do it because of a United Nations mandate. I just think it's fascinating. Sort of 2-part question. Do you think there will be other car manufacturers who will make similar announcements? And second question, while you're thinking about that, is this unique to automotive, or it seems to me that security and compliance apply to a lot of things, not just big, heavy, moving mobile iPhones, as you call them, or whatever. It seems to me that this could affect a lot of products, not just cars. So, first question: do you think would you be surprised if another automotive company announced something similar? There's a lot of old cars out there.
Yeah, I mean, I would be surprised to see other OEMs are making similar announcements, because I would have thought that they would have done so in a similar vein.
Checks. Yeah.
Exactly.
Okay, so that's the good news. Hopefully it was the only one. Happens to be the car that I drove, but hey, maybe it's resale values have gone up. Because there's not very many of them out there. But what about other products other than cars? Is this really limited to cars, or it's just a big IoT device, isn't it?
When you look at the car and the number of sensors within it, the number of different components in it, it is, one of the most complex IoT devices in existence today. So it's not surprising to see that this type of regulation has touched upon the automotive market first. Not only because of its complexity, but also because of its criticality in that it needs to be safe, essentially. What I do believe is that we're going to see more instances of these types of things start impacting wider IoT verticals. The network itself, moving forward, is increasingly more and more viewed as critical national infrastructure. There are other verticals within IoT that are fundamentally viewed as critical. They already have regulations, but let's see how that impacts the players within the ecosystem itself. But really, certainly from what I've been seeing over the past 12 months, is things like compliance and security, things that we don't really like to talk about that much, are going to become more and more coming to the fore in over the next few years, for sure.
And the final question, then, talking about the next few years, you made the point about 5G, and it's been 5 years and still nothing substantial out there yet. I'm paraphrasing. I know a lot of operators do listen to this podcast. I've said before, because I go to Mobile World Congress and they go, "Oh, you're the guy who does that podcast." Where do you think we'll be? I'm not going to do 5 years because it'll make it too easy for you to say, "Oh, yeah, well, I think we'll have made substantial progress." But let me say 2 years from now,
Mm-hmm.
what do you think we'll be with 5G? Is there a breakthrough on the horizon, be it regulatory, be it a technology breakthrough, a capability 2 years from now?
So the first priority really for most operators is getting what's called VoLTE roaming sorted out. So voice over LTE is implemented in many markets for domestic voice calls. The way that the networks are changing in 5G means that you can't use, let's say, legacy voice technology. So you have to rely on VoLTE. And in a roaming context, that's been quite difficult. It's kind of been left to the last minute. And when you go to the wholesale agreements and solutions conferences, there's generally, let's say, quite a lot of work being on discussion being done on that side. That's kind of taken up a lot of operators' priority. Another thing to consider is how wholesale is monetized for roaming. So there's a new framework called Billing and Charging Evolution. It adds things like radio access technology recognition, adds things like more flexible charging models. So not just based on data, things that the old legacy framework can't do and can't really effectively monetize 5G with. That's going to be introduced. And we're going to start seeing that from next year onwards. I mean, we're already seeing a few, let's say, BCE, Billing and Charging Evolution agreements in place. That's going to ramp up, and that provides the baseline for rolling out 5G roaming. So from next year, we'll start to see, let's say, 5G standalone roaming start to be rolled out. And that's when we can start to take advantage of, like Larry mentioned, the URLC use cases and things. But 2026, from a market perspective, I would expect perhaps less than 100 million IoT devices using 5G or roaming IoT devices using 5G, a lot less than 100 million. So it's really only going to get started over the next couple of years.
Right. Okay. Well, they say you should, if you're going to give a prediction, you should never give a number and a date in the same sentence. You've just done that. So, but I guess that's why you're an analyst, right? I mean, that's
Yeah.
why you're an analyst. So really, that was a very good conversation. I hope the listeners agreed, indeed the viewers, if you watch this on YouTube, with the three of us on. And it's a really big subject, and as you've heard, there's still a lot of issues to resolve. One thing for sure, from my perspective, is that collaboration between the operators, between all the players, this is not something that one big company on its own can solve. It absolutely is going to require collaboration. And whether that's everyone collaborating at the same time and moving at the same time, which I'm a skeptic of, or whether it's a group of people, operators and players collaborating to leapfrog us forward, collaboration is needed, because one thing for sure is that the customers want this and they don't want to wait such a long period of time for these breakthroughs, which technically offer so much promise to use cases. But in the meantime, I want to thank both of you. And Larry, I can see you're
Nick, a
eager
quick
to
comment.
make one more point.
Yeah, just based on my experience at Accenture, I just want to put out what I think the consequences if the operators don't collaborate on this. If they don't come out and figure something out, the enterprises are going to solve it by themselves, or they're going to go to the Amazon and the hyperscalers to solve it for them. So I really think they've got a burning platform to really figure this out, or to be solved for them. And I don't think that's what they want to happen. So I'll put that out there.
You know what? It reminds me to finish off that there are two reasons why people move quickly. One's called greed, and the other one's called fear. And so you just introduced one of the two. But I would also argue that getting this right creates a lot of money and a lot of value for everybody.
Yeah.
It's always good to have the what happens if you don't do this, if you don't collaborate. So on that point, we're going to leave it here. Steffen, as always, thank you very much. Number 3, who knows? At some point we could be doing number 4. Maybe we start by revisiting your prediction. And Larry, thank you for jumping in, and your as you said, you've spent most of your career looking at this subject, so I know there was a lot more you would have wanted to deliver on this. But you have been listening to the IoT Leaders podcast. Thank you very much. And from me, your host, Nicole, CEO of Eseye, for my 2 guests on these big subjects that may seem technical, but can actually cause the obsolescence of Porsche's #1 selling car in EMEA, which is really quite significant when you think about the ramifications of what is coming towards all of us. So we'll leave it there, and thank you for listening to this podcast, and I'll talk to you on the next one. Thank you.